All right, section 8.3. This thing is called special right triangles. Or as my grandmother would say, spatial.
That's what my grandmother says.
Spatial. That's so spatial. All right, so special right triangles. Well, she doesn't say it anymore because she's not alive, but she used to say it like that.
Is she from the
All right,
South?
she's from West Virginia, yes.
That's where mine
Both my grandparents are from West Virginia. Both sets. So anyway, special right triangles. Now, the reason these are special right triangles is because this one right here, this side and this side are equal to each other. So tell me something. If I know, first of all, what's the name of this type of triangle? It's a right triangle, but these two sides are equal, so it's isosceles. Right. Well, it's not a cube because it's a right triangle. Okay, but it's an isosceles triangle. You listening?
Yeah.
All right, let's pay attention up here. Okay. All right, these two sides right here are equal to each other, so it's a right triangle. Tell me something. What I'm concerned about in this lesson are the angles. What are these angles equal to? I know this is a right. Okay, are they equal to each other?
Yes.
Yes, they are. Because if I have two sides that are equal to each other, the angles opposite those sides are going to be equal to each other as well. So tell me what the degree measure is.
30, 60.
Wow. No, it's not. They have to equal each other.
30, 30. 110.
No.
They got to equal each other, and they have to add up to what?
180.
Well, all three of them have to be 180.
45, 45.
They're 45, right? This is 45. Why is it 45? Because these two add up to 90, right? 90 plus 90 is 180. Are you guys listening? So these two have... Christian, I just asked you to be quiet, and I start talking, and then you say something. Don't do that, please. These two angles right here are equal to each other. They add up to 90 degrees, because if this angle is 90 degrees, the other two angles have to add up to 90 degrees. Would you agree? Because they add up to 180. So if you split 90 in half, right, if they're both equal, then they're both 45. So these two are equal, yes, because it's an isosceles triangle, okay? So watch, this is we call this, we're going to do two types of special triangles today. The first one is a 45, 45, 90, all right? So that's our first special type of triangle. Now they're just dashes, 45, 45, all right? They're just dashes just to separate them. Everybody got that? And they represent the degrees of this right triangle. Okay, now let's think about this. I want to show you, at least on this one, I probably won't do it for the other one, but at least this one I think you can handle this. If these two sides are equal to each other, let's call this A. If this is A, what am I going to call this one?
B.
Yeah, but if they're equal to each other,
A.
call it A, right? Okay, call it A. Does it make sense? All right, what I want to do is I want to find this hypotenuse right here.
You just call it E.
You can if you want. We'll call it hypo. All right, so watch. What would we do to find the hypotenuse? Now, I don't know what the actual number is here, okay? But what would I do? I take the hypotenuse, what? Squared, because it's a right triangle, I can use Pythagorean theorem, right? So the hypotenuse squared equals what?
A squared.
A squared plus A squared. Now, this only works when these two sides are equal to each other, okay? So H squared equals A squared plus A squared. Now, look. I'm showing you this for a reason, I promise you. What's 1A squared plus 1A squared?
2A.
2A squared, good. 2A squared. Now what am I trying to do? I'm trying to find the hypotenuse, correct? Okay, so what am I going to do? Square root both sides, correct? Right? We've done that the last couple days, haven't we? All right. So this is going to be just H, right?
2A.
It's not 2 because it's under a what?
Oh, a square root.
It's under a square root, so it's not a 2. What is it?
1.
No, forget the A right now. Just look at the 2. What is it?
Nothing.
Still haven't heard it. It's under a square root. So it's a...
0.
Oh my
One.
goodness, people. Bro, you're just bored.
Square root.
Square root of 1? Why are we saying square root of 1?
Square root of 2.
Square root of 2, right. It's the square root of 2. Okay? That's the square root of 2. Now what about this? What's the square root of A squared?
A.
It's A, right. Exactly. You see that?
Good job.
Okay, now, there's a reason I wrote it like this. What is the A? It's one of the legs of the triangle, isn't it? No, it's not under the square root. Because watch. Remember we talked about this rule the other day? I could split these up, right?
Yeah.
Take the 2, put it under a square root, and put the A squared under a square root. There's a rule in algebra that says we can do that. Well, the square root of 2, I can't do anything else with that, can I? So it's just the square root of 2. But what's the square root of a squared? It's just an a. It's not a squared, is it? It's just an a. You with me? Now, why in the world did I do that? Well, I'll show you. That a was one of the legs of the triangle, correct?
Yes.
So, look. Here's a relationship. Put it in a box, circle it, do whatever you need to.
Take away the A.
Okay? I just replaced it with the word leg because I'm being general now. Okay? So when you have a 45, 45, 90 triangle, what's the relationship between, let me put this triangle here again so we can see it.
The hypotenuse.
What is the relationship between the hypotenuse and one of the legs?
Hypotenuse equals
The hypotenuse, and that's a leg right there, and that's a leg right there,
square root of 2
times, right? Not plus. There's no plus there. That's times. Okay? The hypotenuse is equal to what? The square root of 2, not 2, the square root of 2. It's a different number. What is the square root of 2? It's like 1 point something, right? 1.4, I think. All right? So the square root of 2 times one of the legs. That's what the hypotenuse is equal to. All right? Let me do a quick example and show you how easy this is. And it's really nice because you don't have to go through a lot of Pythagorean theorem and all this other kind of stuff. What you can do is you can just look at this and say, if I know that this side and this side are equal to each other, let's say I knew the length of that side. Let's say that was 5. Okay? What would the length of this other leg be?
5.
That would be 5. That's easy because you know their two legs are equal to each other. Dion, you getting all this? You want to pay attention to this, I promise you. Okay, so this and this are equal to each other. Now, without going through Pythagorean theorem, you could if you wanted to, right? You could do Pythagorean theorem here if you wanted to, but it's a lot easier recognizing that you have a 45, 45, 90 triangle. Once you recognize that it's 45, 45, 90, what's true about the hypotenuse? The hypotenuse is equal to what? The square root of 2 times one of the legs. So it's the square root of 2 times what?
5.
5, right. But we don't write it like that. When we do square roots, we always put the whole number out in front. So how would I write it if I put the whole number out in front? 5 square root of 2. And that's how you want to write your answer, just like that. You hardly had to do any math at all. In fact, you really didn't do any math, did you? Did you really do any arithmetic or anything? All you did was put what? A square root of 2 next to the 5 to get the hypotenuse. That's all you had to do. That is solved. It's solved already. That's why I put a circle around it. It's already solved. That's how you want to write your answer. It's pretty simple, isn't it?
Yeah.
Okay, let's do another one. I'll make it just as easy, and then we'll make it a little bit tougher. Okay. I mean, you could, but why bother? Right? You already had 5 square root of 2, right? Is there really any need to put it into a calculator? There's really not. You already had your answer. Just leave it like that. That's what I would do. What if this was 3? What would the hypotenuse be?
H equals 3 times the square root of 2.
That's right. It'd just be 3 square root of 2. As simple as that. Right? And of course, this would be 3, wouldn't it? All right? You with me on that? That's easy. So if the sides are whole numbers, hypotenuse is easy. It's just that whole number times the square root of 2. All right? Let me ramp it up just a little bit. What if this was the square root of 5? Then this bottom one would be what? Square root of 5. Then what's this going to be?
2, the square root of 2 times the square root of 5.
That's right. It's the square root of 2 times the square root of 5, right? You just take the leg and you multiply it by square root of 2. That's all you do. Does it make sense? So you just take this, multiply it by square root of 2. What is square root of 2? Look, let's punch this in a calculator and look at it. Square root of 2. Square root of 2. See, it's 1.4142, blah, blah, blah. So it's 1.4. So it's not quite 1.5. So what does that mean? That means the hypotenuse is 1.4 times as big as the leg. Do you see that? So the square root of 2 is kind of like 1.4. So what does that mean? It means this is 1.4 times as big as this. You got it? Every time, no matter how big your triangle is, no matter how small your triangle is, the hypotenuse is always 1.4 or the square root of 2 times as big as either one of those legs. You see it? All right, so whatever the leg is depends on what your hypotenuse is. You can simplify this, though. What's the square root of 2 times the square root of 5? Square root of 10. It's as easy as that, right? You got 2 square roots. You just put them both under one big square root. 2 times 5 is 10. You just put it under one big square root. Yes, sir.
Alright, so if it's a whole number, it goes in front of the square root of 2, right?
Yeah, it really doesn't matter how. If it's a square root, I could have written it like this, right? I could have put that number in front of the square root of 2. It's the same exact thing, right? I mean, think of it. 2 times 3 is the same as 3 times 2, right? It's the same thing as this. So that also equals the square root of 10. So it really doesn't matter which one goes out in front. But when we do whole numbers, it's the looks of things. Like, I wouldn't go square root of 2, 5. That just doesn't look right. Even if I put a dot here, that just doesn't look right. It just looks a lot better if we write 5 square root of 2. Does it make sense?
Yeah, that's all.
That's why we put it there.
But does it matter which way you write it? Like, do you have to do
This-
square root of 10?
Like right here, this is not the square root of 10 because the 5 is not under a square root. You can only multiply these two numbers together if they're both under a square root. Okay? Let's do another one.
Do you have to put square root of 10?
I want you to put it as a square root of 10. Do you have to? No, but what's the purpose, really?
Could we have just kept as square root of 2 for the square root of
Oh, on that one, you definitely should multiply. I mean, look, if you're doing a math problem or you're doing an algebra problem, you're doing the work and you come down and it comes down to 7 times 3. Are you going to leave your answer 7 times 3? No. How are you going to write your answer? 21, right? So, if you come down to a problem and it's the square root of 2 times the square root of 5, are you going to leave it like that? No, of course not. You're going to multiply it together, all right?
Okay.
You're always going to do that. Make sense? All right. So let's do another one. Same kind of deal. I'll just stick another number in here. What if we use the square root of 7? All right, so if this is square root of 7, the bottom is the square root of 7. What's the hypotenuse going to be?
Square root of 2 times the square root of 7.
Right, it's the square root of 2 times the square root of 7. And what does that give you? Square root of 14. Just leave it like that. Now, can you put this into a calculator and say the square root of 14? Yeah, I guess you could. But why bother? Why bother doing that? It's 3.7, all right? So it's approximately 3.7. But look, why bother doing that when I will accept this answer right there? That's perfectly fine. Okay, I know you can put that into a calculator. That's not that big of a deal. I would just leave it like this. If I was doing the problem, I would leave it the square root of 14 and be done with it. You okay with that? Okay.
So, it works like you want us to do the square root times the square root.
Yes, you always should do that.
Even if it's like a decimal or whatever, you still want us to do it like that? Oh no, psych, that wasn't my question.
If you had a whole number out in front of it, like if this was a whole number, watch, if this was 9, then this would be what? 9 square root of 2.
Yeah.
Okay? That's all there is to it. Everybody see that? If this was, let's just do a bunch in a row just so you get the idea. If this was a 2.3, let's say that was 2.3, then what would the hypotenuse be?
2.3 times the square root.
Exactly right. Then you would just write it like that. Now that's kind of a weird way to write it. If you wanted to put it into a calculator and get an answer, that's fine, but I would accept that. That's perfectly fine. Just leave it like that. Okay?
So then, this is the only thing that's confusing me. You're writing it like that, but then like, when you do the square root of 2 times the square root of 5.
Yeah, because it's a square root.
Oh, okay.
Okay? So if this was a square root of something, the square root of 10, then what would this be?
Square root of 10 times the square root of 2.
Which is?
Okay, I forgot that
Right.
we did ones with just like
Yeah,
numbers
if you have
without
it,
square root.
right, if you have a square root times the square root, then you should multiply them together and get the square root of 20.
Okay.
Just leave it like that. Okay? All right,
But if it's just a whole number, write it. the
just
way
put
we
it out in
read.
front of the square root of 2. That's all you got to do. Okay? Everybody got it? What if I did this? What if I said this was 7 and you had to find this one right here?
Oh, no. What did you do like the reverse like that? No.
It is kind of the reverse. Look, see how this thing's in a box?
7 equals.
Watch, what did we do to x to get to this? We multiplied it by what? Square root of 2 to get to this. How do you think we're going to go the other way? We're going to divide it by the square root of 2. Yeah, look. Because watch, if I wanted to solve for the leg right here, how do I get rid of this thing? Divide by the square root of 2. So the leg, you don't have to memorize this thing right here, but watch, the leg is the hypotenuse what? Divided by the square root of 2. You see it? You don't have to memorize this thing that I just wrote down. You could memorize this in the yellow. Memorize that one. This one, you could figure it out. See, if I get leg by itself, right, because leg is a number, right? It's a variable. How do I get rid of something that's being multiplied? I always divide. Divide this side by square root of 2, it cancels. Divide this by square root of 2, and that's what you get. So, how would I get this answer right there? What is that? It's going to be what?
X
7
equals
over square
Well, the
root.
leg, right, which is x, you're right. X equals what? The
7
hypotenuse.
divided by square root of 2.
That's right. Now look, I'll let you keep it like this. But when you get to algebra 2,
Gotta simplify.
they don't like the square root in the denominator. You ever hear that in your algebra 1 class? Yeah, it doesn't seem like you did much with square roots. So there's a way to get rid of it. I'm not going to bother you with that right now. That's too confusing for you right now, okay? But you can just leave it like this. I'm fine. At the level that we're at right now, geometry, I'm fine that you keep it like this. When you get into algebra 2, then I'll have a problem with this. All right? But for right now, I'm okay with just leaving it 7 over square root of 2. Make sense? So that's not so hard, is it?
No.
Just got to keep it straight which one they give you. So if they give you the hypotenuse, how do you find the leg? You divide by the square root of 2. If they give you the leg, how do you find the hypotenuse? You multiply by the square root of 2. Got it? Okay. What if they gave you this as like the square root of 10? How would you find this? You still do what?
10 over square root.
That's right. It's the square root of 10, what? Divided by the square root of 2. Now watch. I do want you to simplify this. If you have both square roots, just like when we multiplied, remember that? Watch. It's the square root. It's one big square root over what? 10 over 2, which is the square root. Yeah, but you don't need over 1, do you? Just square root of 5. And that makes sense because watch. What if we started off with the square root of 5? How do you find the hypotenuse? You multiply it by square root of 2, which is going to give you what? Square root of 10. Make sense? All right, so if they give you the leg, we multiply by the square root of 2 to get the hypotenuse. If they give you the hypotenuse, we divide by the square root of 2 to get the leg.
So always by the square root of 2.
Yes. That's only on a what kind of a triangle?
Special.
Special.
Well, which special one?
Special, right.
A 45, 45, 90 triangle. Now, there's 2 of them. I don't have time to do it today, and I kind of plan on that anyway. But yeah, I'll just sneak preview here. There's a 30, 60, 90 triangle, and it'll look something like this. Okay? This is a sneak preview for tomorrow. So this is the 30, this is the 60, and this, of course, is the 90. Now look what we have. We don't just have 2 legs. This is still the hypotenuse, right? Look at this leg right here. What is it opposite? It's opposite the 30, which is the smallest angle. So tell me something about that side. It's the smallest side. We call it the short side. Okay? This is the what? This is the, well, it's the longer side. Okay? So we call that the longer side, or just long. So now I don't just have 2 of the same sides. I have a short side, a long side, and the hypotenuse. We'll talk about the relationship between all those tomorrow.
Homework.
Okay?
Come on, homework.
Homework?
There's no homework.
No.
Give us
You
homework.
can't finish it.
I'll give you homework tomorrow. Okay? And it'll cover both. It'll cover 45, 45, and 30, 60, 90s. Yes. I got to get it copied. Give me after 5th period sometime. Okay?
Jennifer!